You are listening to Recording 1B in our series on the sine law for Unit 2, Chapter 2, Trigonometry, Mathematics 2200. We'll be focusing our attention on the ambiguous case for the number of triangles and when it applies, and how to solve problems involving the ambiguous case. The ambiguous case, also known as the donkey theorem, I'll leave that to you to figure out why we call it the donkey theorem. We have several cases when we are given only two sides and the non-included angle for a triangle. We either have no triangle or one triangle or two triangles. Let's see how that happens. Here I'm given two equal sides and an angle not formed by those two sides. Those are the conditions we must meet. Can I bring this side down by rotating to meet the third side of the triangle? So I'll rotate, I'll put a circle there to show the rotation. It meets there, so I now have a triangle ABD, which happens to be isosceles. And if I swing on over towards B, I exactly meet B, so I only get a straight line segment there, no triangle. So I've got one possible triangle. In this case, I've got 4.5, 3.3 as my side measurements and an angle not formed by those two sides. And it looks like the 3.3 is just long enough to barely meet the third side to form a right triangle. Here's a third way to get only one triangle. I've got sides of 4.5, 6.1 and an angle of 47. Let's see what happens when I rotate that 6.1. It meets here. I get a triangle ABD there. That's one triangle, but the line segment is too long to allow D to meet the third side again. So I've only got one triangle. Here the conditions we must meet are that this side is 3.0 centimeters. This one's 4.5, angle of 47 again. And let's rotate that 3.0. Looks like that guy is not going to be too long enough to meet the third side to form a triangle, so no triangle is possible. Changing that side measurement to 3.8 centimeters and 4.5 centimeters here and 47. Those are the necessary conditions. I rotate the 3.8. Oh, look, it meets at one location there to give us an acute angle right in here, and then it meets over here again. And we note, I've moved that 47 out of the way, we note now that we now have an obtuse angle formed right here. Now before we apply that to any problem solving, also recall that an angle in the first quadrant with the reference angle, in this case the example is 22 degrees, that angle would have the same value for sine as 158 degrees because it has a reference of 22. And sine is positive in both quadrants. I look at a problem here, triangle ABC with angle A 30 degrees, A is 24, B is 42 centimeters. We have to determine the number of possible triangles. Setting this up in a guiding diagram that may not be accurate because we don't really know if we got a triangle even, but it's something to guide us. We see that we have side-side angle, the donkey theorem is going to apply, and we're going to use the sine law. So setting up our sine law and punching in the known values and recognizing we don't need this ratio in this problem, we've got this result. And a little bit of rearranging gives sine of angle B equals this, which in turn gives us 0.875 equals sine of angle B. Carrying that over to a new slide, we will find that angle B, therefore, is equal to inverse sine of 0.875, which means angle B is 61 degrees to the nearest degree. Now, that's our acute case. Remember, there's an angle in the second quadrant with the same value for sine. So our obtuse possibility Obtuse angle B is 180 minus the 61, which is 119. Does that give us two possible triangles? Let's find out. Here's what we have for the two triangles that are under consideration. In the acute case, angle B is 61, angle A has to be 30. In the obtuse case of angle B, we have 119 and angle A still has to be 30. So we know that angle C has to be figured out. So if I call them triangles 1 and 2, remember the three angles have to add to 180 degrees for a triangle. I'll just use the triangle symbol. So that means they've got to add to 180. That leaves 89 for angle C here and 31 degrees for angle C in the second case. So we have two possible triangles. Now before we do our next example, quick recall, the sine of an angle cannot be bigger than 1. We've got another triangle ABC with these measurements. Let's have a sketch. So now I've added my sketch and I've set up my equation, my sine law. Don't need sine of B over B in this case. So with a little rearranging, 2.4620 is supposed to equal sine of angle C. Try doing inverse sine in your calculator, you'll get an error. That's because sine C cannot be greater than 1. So since we can't have a sine value bigger than 1, no triangle is possible. To summarize, when given two sides and a non-included angle, SSA, also known as the donkey theorem, to form a triangle, the possible cases are no triangle, exactly one triangle, or two triangles are possible.